Welcome to qnawire.
So in this question here, we are checking the relationship between if the person died from cancer or not, and if the person was like a never smoker, former smoker, or is still smoking. Okay. So in item A, we are interested in the probability that a male that never smoked died from cancer here. Like we have these two events, and looking at the table, the number of people that never smoked and died from cancer is 712, which means that the probability will be this total given by the total number of people that we have. So if you add all these cells in the table, you're going to have that the total number is, in this case, 144,459. So this is the total to give the probability that we want. So this is 0.0049. Then for B, we are interested in what is the probability that the male was a current smoker and died from cancer. So if you look at the table, was a current smoker and died from cancer, we have 286 out of the total again, which is 0.0020. Then for C, we are interested in the probability that the male died from cancer given. So now we have the given information, given that he never smoked. Because we are given the information that a male never smoked, this means that now the total, the denominator here will be with respect to that specific group, never smoked. So if you look at the row of never smoked, we have a total of 129,596. Now the numerator here will be the same as in item A, because it is the number of people that, in this case, males that died from cancer but never smoked, and that is 0.0055. Then in D, we want to find what is the probability that the male died from cancer given that he was a current smoker. So the same thing, given that was a current smoker means that now our total, our group is only current smokers. So if you add 286 with 5,815, this is the total of current smokers that we have in the table. And this is the number of people, male in this case, that died from cancer and was never a smoker. Sorry, was a current smoker, not never. So this is 0.0469. So these are the probabilities that we have. In item E, we want to compare these probabilities in parts A and B and the probabilities in parts C and D. In one or two sentences, we need to make the interpretation of these comparisons and the relationship between smoking and cancer. So one thing that we need to pay attention is that we have more people that never smoked in the data that we have than people that was like a former smoker or current smoker. So we have this kind of like unbalance here in terms of like people in those two groups. So looking at the probabilities, A and B, for example, we could see that with respect to all males, the total that we have in the sample, if you look at A and B, there is not a big difference between the probability of dying and considering if it was like a never smoker or like a current smoke, but he is saying that the probability that a male died and was never smoked is higher than the probability of like dying in this case as being like a current smoker. So that's what we get when we consider the total number of males. But then that's what I wrote here. Here does not change much, but we could add that it is higher for the group that never smoked, okay, which is strange. Then if you look at C and D, now that makes more sense. Why? Because if we know that the person was a current smoker, here, the probability of dying is much higher than the probability of dying if you never smoked, which makes more sense. So that's important to consider that the totals here, like the groups, the total number of people that we have in the group that never smoked with respect to the group that was a current smoker, former smoker, they are different and by a large amount. So that's why that is important to consider these two different totals. And this one here makes more sense than the other two.